Hello everyone, welcome to this video. In this video, we shall be solving another question from IIT-JAM 2020 examination. This is a numerical answer type question and it is a 1 mark question. So here in this question, you are given some vector f which is xi cap plus yj cap plus zk cap, and s is given to be some sphere which is whose equation is this one. So from this equation, we get to know that the center of this sphere is 2, 2, 2 and its radius is equal to 2 square, which is equal to 4, right? So this is the sphere and some vector f that is given to us. Now if n cap that represents the unit outward normal to the given sphere, right? Then what is the value of 1 by pi double integration surface integral of vector f dot product with n cap, right? So we are to solve and evaluate this quantity over here. So for the solution, first of all, you should know the given sphere S. What is it? How does it look like? So the equation is given to be x minus 2 whole square, y minus 2 whole square plus z minus 2 whole square, that is given to be 2 square, right? So geometrically this would look something like this. So if we draw the coordinate axis here, right, in 3 dimension, this is suppose our origin here. So this is the origin, say this is x axis, y axis and z axis. The center is 2, 2, 2. So somewhere here in the x, y and z plane. So you would have some sphere of this kind with 2 as the radius, right? So this could be your circle, which would lie entirely in the first quadrant, in the first octant in fact, right? So this is your sphere. For this sphere, we wanted to calculate what is the value of 1 by pi the surface integral over s of the vector f dot with n cap ds. So what is this thing? So we wanted to evaluate this thing. For evaluating this, we have the Gauss divergence theorem. You might have studied about this theorem. According to this theorem converts the surface integral into the corresponding volume integral. So by Gauss divergence theorem, we have the surface integral over S over this sphere of f vector dot with n vector ds, that is simply equal to the volume integral of del dot f dv, right? So it is equal to the volume integral of the divergence of this particular vector. Why we are doing this? Because we as such do not know what is the value of this n cap vector, the vector which is unit outward normal to the given surface, right? So as we have applied this theorem, now what is remaining is we just have to solve this right hand side over here. So what is this? It is the triple integral over the given volume. What is the value of this divergence? This del, that is del by del x of I cap plus del by del y of j cap plus del by del z of k cap. So this is the del vector, right? So let's substitute the value over here. So it is equal to del by del x I cap plus del by del y j cap plus del by del z k cap dot product with the vector f. And what is vector f? It is x I cap plus y j cap plus z k cap, right? And we have to perform this integration over dv. So first of all, we have to take this dot product. How do we perform the dot product? We simply multiply I cap with I cap, j cap with j cap and k cap with k cap. So it is del by del x of x, del by del y of y and del by del z of z. This term with this term, this term with this term and this term with this term, and all the other multiplications, they are simply equal to 0, right? So when you solve this thing, you have here the value 1 plus 1 plus 1 times dv. So it is equal to the triple integral of 3 dv. So basically you have this as equal to 3 times of the triple integral over v dv. And what is this thing? This is nothing but this triple integral over dv, that is nothing but the volume of the sphere, And what is the volume of sphere? If you remember the formula, it is equal to 4 by 3 pi r cube, right? What is r in our case? The radius is known to be 2, right? So 2 cube. So when you simplify and solve this thing, it come out to be equal to 32 pi, right? So this is the expression that we have got. But what we wanted to calculate 1 by pi of this quantity. So your final answer, so therefore 1 by pi of double integral over s of f vector dot with n vector ds, that is equal to 1 by pi of whatever we have calculated, 32 pi, which is equal to 32. So finally 32 is your final answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.